Let's solve this problem. If you'd like, you can click the pause button and try to solve this problem yourself before you watch the video. Let's connect point Q to point A and point Q to point D. Since QP is perpendicular to AD and AP is equal to PD, triangle ADQ is an isosceles triangle. AQ is equal to QD. Let's represent BQ as X. Triangle ABQ is a right triangle. By the Pythagorean theorem, AQ squared is equal to AB squared plus BQ squared. Let's sub in the values. AQ squared is equal to 81 plus X squared. Triangle QDC is a right triangle. By the Pythagorean theorem, QD squared is equal to QC squared plus CD squared. Let's sub in the values. QD squared is equal to x squared minus 16x plus 113. Since AQ is equal to QD, we can equate these two expressions, and after simplifying the equation, we are left with x is equal to 2. We can find AQ using this formula. AQ is equal to square root of 85. The area of a right triangle is equal to half the product of its legs. The area of the triangle ABQ is equal to 9 square units. Let's draw segment DE perpendicular to AB. DE is equal to BC and equals to 8. BE is equal to CD and equals to 7. And AE is equal to 9 minus 7, which is 2. Triangle AED is a right triangle. By the Pythagorean theorem, AD squared is equal to AE squared plus DE squared. Let's sub in the values. AD is equal to 2 square roots of 17. AP is equal to PD and equals to square root of 17. Triangle APQ is a right triangle. By the Pythagorean theorem, QP squared is equal to AQ squared minus AP squared. Let's sub in the values. QP is equal to 2 square roots of 17. The area of a right triangle is equal to half the product of its legs. The area of the triangle APQ is equal to 17 square units. Now we can find the area of the quadrilateral APQB, which is equal to 26 square units. Thank you for watching. If you found this video helpful, please consider to subscribe to help my channel grow. Thank you.